This episode of the HVAC School Podcast is made possible by our great sponsors, Carrier and Mitsubishi Electric Cooling and Heating. Also want to thank UEI and their Hub Smart Kits, specifically their thermohygrometers, which are the induct temperature and humidity measuring probes, their pressure probes, as well as the temperature probes that go along with the pressure probes. They are the Hub 6 kit for all of them together, the Hub 4 kit for the pressure probes and clamps, and the Hub 2 kit for the thermohygrometers. They are available now at many fine retail establishments, including TruTechTools.com, TruTechTools.com. Also want to thank Refrigeration Technologies, makers of the Wet Rag product that helps protect your work from being damaged when brazing or soldering. Great product, as well as their Viper line of cleaners, Nylog, assembly lubricant, and thread sealant, and especially their new pan and drain spray, which can often take the place of what many of you are using pan tabs for. Lasts a long time and does a great job at breaking down the stuff that grows in drain pans over time. Also, thank you to AirOasis, their bipolar in-air handler product that mounts on the side of a blower housing that helps create bipolar ions that go out and attach themselves to particles in the airstream and help disrupt live organisms that are growing in your air that you don't want, and their Nano product, which is another great induct product for actively treating air.
Meet ZoomLock, the 10-second flame-free refrigerant fitting from Parker. Reduce labor costs by 60% with no brazing, no flame, and no fire spotter. Discover how ZoomLock can help you be more efficient and productive. Visit ZoomLock.com for more information.
You know that friend who keeps interrupting your great story to adjust your facts? Just slightly? He's like that. Here's Brian Orr.
Thanks for being here. This is the HVAC School Podcast. I am Brian, and today on the podcast... Oh, wait, first I have to mention this podcast is the podcast that helps you remember some things that you might have forgotten along the way, maybe helps you remember some things you forgot to know in the first place. And I can assure you that for most of us, this is something we didn't know in the first place, and that is how to easily and effectively seal leaks on aluminum coils or pinholes on aluminum tubing or anything related to repairing aluminum. Today on the podcast, we're going to go through specifically one way that you can go about doing this, and I think you're going to like it. So here we go. We've got Lance Robinson with SolderWeld talking about how to repair leaks in aluminum. All right, so today on the podcast, we have Lance Robinson. I think you are called the king of SolderWeld. Is that your exact title?
I don't know if I would go that far.
Chief Magistrate.
Yeah, there you go. That sounds good.
Of SolderWeld. Okay, yeah, very good. So Lance actually just finished up a training on aluminum coil repair, and that's what I wanted to talk about today because it's an area that I'm very interested in. I've tried a lot of products over the years and have not always been real satisfied with aluminum repair. So let's talk about that just to start off. Let's open up with, why has aluminum repair been so difficult in the past?
Well, first of all, if you go back in time quite a bit, a lot of these companies, including General Electric, all were using aluminum for a very long period of time. If you go back into the 70s, when you saw your first air conditioning unit built, well, of course, not everybody had that. Prior to the 80s, it was probably 80% of the homes didn't even really understand what air conditioning was, and it was a luxury, if you will. To give you a little bit of an idea behind this, aluminum is a strange metal, but it's extremely effective for corrosion, for hindering corrosion and not allowing for some of the things that we deal with copper. As an example, if we kind of look at brazing in the HVAC world out there, high strength brazing is very important. We want to braze and we want hermetic joints that can withstand the pressure, vibration, thermal cycling, all of these things that happen on a daily basis while we're not paying attention. Copper's always been the choice. The problem with it is, well, of course, the good of copper is it's got great transfer properties. It's ductile. On that time, it's easy to join. And we deal with brazing copper with Silphos, and Silphos has been around since the 30s. The reason that so many companies are going towards aluminum is the idea that it has some really strong potential for long lasting. We don't have to worry about corrosion issues that we'll deal with in galvanic and formicary corrosion. So to give you a good example, let's look at it from the idea that if you put aluminum and copper up next to each other, the surface to weight ratio, a pound of aluminum, it yields almost probably 3 times the amount of parts a manufacturer can create than a pound of copper. They're looking at it from that standpoint, of course.
Yeah, so there's a lot of advantages to aluminum. And of course, we're talking to a group of people who love copper. We've cut our teeth on copper, probably quite literally in some instances, and it's what we know. And when something new like aluminum comes out, it makes us a little uncomfortable, but there are some huge advantages. It's definitely a lot lighter, which makes the equipment easier to handle. It's not as susceptible to form-of-carry corrosion, especially ant nest corrosion that we've seen in evaporator coils over the years. We've had so many issues with that. I think my first exposure to an all-aluminum coil was a 1986 Carrier evaporator coil that I used to service back when I first started in the trade at a bank. And I remember opening it up and seeing that all white looking coil. And I was like, what the heck is this? And I was talking to one of the senior guys and he's like, yeah, that's an all aluminum coil. And yeah, we never had any issues with that coil. In fact, it was also funny because it was an all aluminum coil and it had a TXV. So for those of you who think that those technologies are new, those have both been around for a very long time. And in many ways, we're almost revisiting the past. But we've seen so many issues with form-of-carry corrosion, especially in evaporator coils, that it makes a lot of sense that manufacturers are looking at this. But I remember kind of my first exposure with trying to repair aluminum was a case where I had a technician put a screw. I mean, I'm sure I had tried it before in the past, but this was the first time that I really needed it to work. And a technician had put a screw in a train condenser coil. And my goodness, we could not get that to work. We could not get it fixed. It was a real frustration. So let's talk about, like, you make a specific product and it's designed specifically for soldering aluminum, and what makes your product different?
All right. So there's a lot of other aluminum type repair products on the market. And just as you said, you're going to have problems with them. They flow out at a higher temperature. In a lot of cases, they will flow out at upwards of almost the near melting point of aluminum. And everybody is probably aware of this, and I'll go ahead and say it anyway. Aluminum melts at that 1190 degrees Fahrenheit, or that just a little over 600 degrees Celsius. So it melts very easily and quickly, and it doesn't give us any distinctive property telling us that it's going to melt. With copper, of course, we know when the copper is at temperature. When it hits that sweet spot and it's glowing and it's changing color, that's great. But the aluminum itself, it literally, as you said, you have a screw hole in a condensing unit and you want to fill it. Well, what ends up happening is most guys, they'll go out there and they make a bigger hole than what the screw did. And trying to fix it, and then they just pinch it off and they hope for the best. Our product, the alloy sol product, is a solid core rod, and it has the flux on the outside. Now, this is the only flux in the industry that decontaminates the aluminum surface for you. So it allows you to be able to prep the aluminum without having to do what we normally do with copper, and that is clean, and get it prepped and then prep it some more. So the flux decontaminates the aluminum surface for us and allows the bond to the aluminum rod to the parent metal, the aluminum. Now, the bond flows out. Now, just so we're on the same note here, the rod flows at 600 degrees. And if aluminum melts at 1190, then that gives the tech, that gives all of us a really good working room or working time frame before the aluminum's going to melt on us.
This alloy sol is a solder because it's below 840 degrees. For those of you out there who struggle with the differences here, when you get below 840, you're dealing with a solder. When you still use a different metal for the joining than the base metal, then it's considered to be brazing, and that's above 840. And when you're joining two metals together with the same base metal, then that's where welding comes in. So we're talking about a solder here. You mentioned something which is flux, and a lot of us, I think, don't even really fully understand what flux is. So I'm just going to back up and very quickly help everybody get their minds around this. Flux allows the solder to bond directly to the base metal. It helps deal with and eliminate those oxides that tend to build up. Because when you're adding heat to metal, let's say copper, what we're traditionally used to, we see that carbon start to build up pretty quick. Those oxides start to build up, and a lot of solders don't bond very well to those oxides. They only bond well to the base metal. And this is especially true when you're doing copper to steel or copper to brass, or if you've dealt with those sorts of base metals, you know that any oxides that get in the way there, especially with the high silver solder, it can have some real issues. But even in those cases, we're still talking about brazing because we're talking about that higher temperature, where this is at a lower temperature. And the flux does clean the base material, but it also provides you with some really cool hints as far as when it's time to start to apply the metal. So before we go through the step-by-step process, would you mind talking about that a little bit, how that flux works, how it's applied, and how it can give you some clues?
Yeah, I'm glad you brought that up. The flux is really the kicker, the secret weapon, if you will, the special sauce. Well, when we designed and created this flux, it was for the purpose of being able to allow the tech to know what the temperature of the aluminum was, so they're not trying to guess. As I said before, aluminum literally goes from 0 to 60. So you put some heat on it, and if you put too much heat on it, before you even realize what's happening, that aluminum is melting, you've got a big hole. With this flux, it's a powdered flux. And so what you'll do is you'll heat up the end of the rod, you'll dip it in the flux, and then you'll melt the flux onto the coil or the U-bend or the microchannel. And when doing so, it's going to go on in a white paste. That white paste tells us that it's bonded and adhered to the aluminum, and it's beginning the process of cleaning. Now, we introduce the heat to it. Now, whether you're using oxyacetylene, I have a lot of guys that prefer MAP gas and propane. And at this low of a temperature, Brian, propane is no problem. You can use propane, a blue tank, to be able to do this. Going any lower than that, remember, we have to get to 600 degrees. Oxyacetylene has been a great tool. You have already got it on your truck. A MAP gas torch is a great tool. Just be careful when dealing in microchannel because it puts out such a big flame. With oxy, at least we can pinpoint our flame right to where we want to work. And we're going to bring the heat and start to activate the flux. And as the heat travels over the flux in kind of a perpendicular fashion, we're heating up the flux and it's going to begin to prickle the aluminum, begin to clean and decontaminate the aluminum and allow for a bond. When that flux goes clear, the aluminum has now hit 600 degrees. So it's a perfect temperature guide and it tells us exactly when to now lay the rod in that fix or that hole or that break, or if you're bonding two tubes together, you're joining them together. This is a perfect rod for that.
When you think about welding or brazing or soldering, we're kind of spoiled. And you mentioned this already. We're spoiled by copper because it gives us so much in the way of visual cues. Guys who are out there who have done TIG welding for years or different types of joining, you know that the visual cues that you get from different processes based on the type of base metal that you're using, based on the type of rig that you're using, but all of us have to have a visual cue that we use. Otherwise, you can kind of do it by feel, but even that, I mean, you have different thicknesses of metal, you have different temperature being applied, different distances. You can't do things blind. And so what this does is it gives you that sense of when that flux goes clear. And those of you who have done dissimilar metal joining with fluxes in the past, it's very similar to this. But the one thing that is unique, and this is a process that I haven't seen before, which is interesting, you're almost using the rod like a brush to apply that flux on. So you're heating it up, you're dipping it into the powder flux, and you're kind of putting that onto the surface that you're joining, and then just watching it, and when it goes clear, then you're ready to start applying the solder, if I understand correctly.
Correct. Remember on this is something very, very different than what we're all used to. When we go out and we're dealing with copper, we're turning the torch on and we're turning it on high. With aluminum, we want to back it off. We want to feather out that flame. We want to make sure that we are controlling the flame because we can get to 600 degrees very quickly. The flux acts as a helpmate, if you will. It actually tells us, okay, you're at 600 degrees. You need to back off a little bit. And the flux will go clear and that hole will open up. And at that moment, all we're going to do is just lay the rod over the top of the hole or lay the rod on the U-bend. And the really cool thing about the flux is that you can do this upside down. You can be in a tight quarters. It doesn't matter. You don't have to be doing this on a work table or in an open space. The flux bonds only to the aluminum. It allows us to be able to make repairs in tight quarters like we deal with on a daily basis. Also, when we lay the rod itself bonds and flows into the aluminum and allows for a perfect repair and a complete repair, Brian. So this is not a temporary repair and hope that Carrier's going to replace the coil for you. This is a complete repair. You're never going to have to worry about that bond ever again. And great thing is with it is in 25, 26 years that we've been in business and teaching and educating guys how to fix aluminum, The great thing is that this right here is something that we are on the verge of all of these manufacturers going to aluminum, both indoor and outdoor.
So we're going to see a lot more of it, and so you got to be prepared to make these repairs in the field. I think everybody kind of gets that. There's still the group that says, why do I need to repair it? I'll just replace the coil. But as we move forward and these are out in the field longer, it's going to be a real benefit to your customers if you can make good, solid repairs.
Something that was very interesting, I don't know if a lot of the guys listening in on this podcast have been to the AHR, the ASHRAE convention, but AHR in Chicago last year, I spoke at one of the events for new technology and emerging technology, and something was interesting. I had a couple of the higher ups, if you will, from Lennox stop by. They wanted to talk to me about this, and they said they're researching frantically in how to be able to make this happen, because one of the main points that all these companies, all these manufacturers, and all these major companies that deal from the commercial side of it, they're tired of replacing coils. In fact, they'll admit that they send out a coil. In some cases, that coil might be flawed. It might have a leak in it, or the brazing process of the aluminum didn't set and you've got a pinhole the second you install this coil. They don't want to have to replace it. It's way too costly for them. So they want you to be able to fix it. And if these warranties go up, you're going to have to fix it anyway. So we want to be able to just make sure that everyone's prepared for this.
Yeah, and besides the fact that if you think about this just from a common sense and sustainability standpoint, it does not make sense for us to be yanking out these big coils, sending them in to be recycled, taking brand new coils and putting them in. It's just a terrible idea. If we can do things properly in the field, be workmen, know how to do these things properly, then it's not going to be an issue. And for those of you out there who are listening thinking like, I don't know about this, well, think of it this way. A lot of you are the same ones who will complain about new products that come out. A lot of people have talked about Zoom Lock and how Zoom Lock is taking the skill out of the trade. I don't happen to believe that at all, but there's some people who think that. Well, this is going the other direction, right? We're taking something that we have the ability to now make a repair instead of just being a parts changer. And if we can do it right and we have products that do the job and it is a permanent repair, then why not at least pursue that and develop those skills?
I think that as well on those lines is that it's important for us to provide the training. And this is something that we do. I mean, as I know, Brian, you're very well aware of, we travel all over the United States to the major HVAC companies out there and some of the smaller HVAC companies and single techs. And we'll teach them step by step how to be able to repair aluminum, even though it's not quite time for it yet. They're only seeing 1 or 2 repairs a month, or some of these techs aren't even seeing a single repair. But if we can hit the colleges and get techs ready as they're entering the field, and we can also get the techs that have been in the field for years and years and years, and they don't like aluminum, but we can show them a really great product, a one and only product that flows beautifully, complete repair, and they're not going to have problems with it like they do with all the rest of the material on the market. If they can make a repair and it's easy, then they're going to. And especially if it looks good.
I want to take a quick second and mention AirOasis and the bipolar product. It's been a long time that I've had different companies talking to me about indoor air quality products and wanting to partner with HVAC School, and I just never felt great about it up until now. And we are using AirOasis products. We're using the bipolar product and the nano product from AirOasis at Kalos. I've been very happy with the way the products are built, which is important. They've got to last, they've got to work, they've got to do what they say they're going to do. They've got to be well built, and I'm very comfortable with how they're made. They're not only made in the U.S., but they also source most of the parts from being made in the U.S. as much as possible. John Bennert is one of the owners, a guy who I've had a chance to talk to at length, and I really trust the things that he says. He's definitely not full of it. The bipolar product, what it does is it creates bipolar ions, which means positive and negative ions. It mounts right on the side of the blower housing, so it's a very easy install. And those ions go out into the airstream and they bond with small particles in the air. And they especially help deactivate some of those live particles that you're most concerned with. Again, I don't understand all of the science. I do know that we've done testing with Petri dishes before and after, and we've seen good results. Some people are like, does it kill 99.9%? Well, it does when it comes in direct contact with them, but keep in mind that this goes out into the airstream. It's not a magic pill. It's not going to fix every single problem, but it does what it says it's going to do. If you look on their YouTube channel, he's got a really nice video that shows what happens with smoke with bipolar. When they put a bipolar ionizer in with a smoke chamber, how quickly the smoke dissipates versus not. So it's great with things like odors. It helps with that. It helps with particles. It helps with VOCs, all those. And the bipolar is just a really nice, easy product to install. It's got no moving parts, but yet when you power it up, you can put your hand over it and you can feel the airflow in between the brushes because of the generation of the positive and negative ions. So it's kind of a neat way that you can actually feel the fact that it is working, even though you don't see any moving parts. It's a great product that I feel comfortable with. If you ever have any concerns with the manufacturer, any of the manufacturers, anybody who's on this podcast who I talk about, you can always reach out to me, Brian at hvacrschool.com. And again, I only want to hear people who have like real understanding, not like, oh, I like this brand better. I chose Aeroasis specifically because I don't think it is a sales pitch. I think it's just good, solid, well-engineered product. It's not a silver bullet that's going to solve every problem, but it's well made. And you can find out more by going to their website, which is easy to find. It's aeroasis.com. All right, so let's start from the top. Some of this is going to be redundant, but I just want to go through it in order. What are the steps in order to make a good, solid bond with this product? Let's start from step one all the way through, whatever the finish is.
Okay, so step one, I'm a stickler like you are, Brian. I like things clean, so I end up cleaning the aluminum anyway. And just like copper, however you are currently cleaning copper, whatever you're comfortable with aluminum, I just like to Scotch-Brite it up a little bit, just get it so that it's a little clean because it is dirty, there's contaminants and so on. Not necessary, however, I happen to like it. I will then at that point grab out my alloy sol rod, and the rod itself is a solid core rod. And the flux is external and it's a powdered flux. So what we're going to do is take our MAP gas or oxyacetylene and just lightly heat up the end of the rod. We're then going to dip it into the flux, and now we have basically a flux-covered rod. We're then going to introduce the flux-covered rod to where our pinhole is or our break in the line and lay it on top of it and bring the heat over to melt the flux off of the rod onto the hole. Once the flux is off the rod, remove the rod and continue to heat the flux. Now the flux, when it went on, it becomes kind of that pasty white color, and now we're at step 4 or 5 or 6 at this point. However, we want to continue to heat the flux until it turns clear. Now, the best way to do this is, if at all possible, perpendicular to your repair, so straight up and down. And the reason for that is when we normally are using a torch, we're just kind of aiming it at the copper line, and it's no problem because it transfers the heat very well. But with aluminum, the straight up and down on your hole is best because we don't want to put too much heat on a different section of the aluminum as it does want to melt, of course. So perpendicular flame, melt the flux right into the repair. The flux will then go a clear color and the hole will open up a little bit. And when that hole opens up, it's telling you that the aluminum is now at 600 degrees. This is the sweet spot. Back your flame off just a little bit and introduce the rod to over the top of your repair. So if it's a pinhole, lay the rod on top and don't put pressure. Now, this is very important because from a welding perspective, from a brazing perspective, we tend to poke at the repair. We introduce the stick and we kind of poke at it and we add the rod almost in a poking manner. What I want you to do is lay the rod lightly on top of the repair and introduce your heat source directly to the rod. What this will do is it will melt the rod into the repair and give us a perfect bond. Now, here's the thing. I have a lot of guys out there, when they're doing this, they end up with a bird poop sitting on top of their fix. This is perfectly fine. Doesn't matter what it looks like. All that matters is that you have that bond and you have that fix. Now, if you use the heat on that deposit, you can actually mold the deposit around a little bit, but be careful. You don't want to add too much heat because then you're going to open up another section right around where your repair is with the heat. So just be careful on that, but keep your heat perpendicular. Mold the deposit right into the repair, and then immediately when that rod flows, immediately after, remove your heat. You're done. and it will look beautiful. And you can see lots of fixes on our YouTube channel and lots of fixes on our Instagram and Facebook pages. Guys realize that it is that easy to fix aluminum. They were just scared to death of it prior to trying out the rod.
The friend of the show, Andrew Greaves, he's been on before, and a lot of you guys know him, aka HVAC online. He's tried it. He really likes it. He does a lot of work with SolderWeld products. So technicians may ask, okay, so it sounds like we're fixing pinholes, that sort of thing. Is this something that works with fittings? Is that a thing yet, or is that not really a developed industry yet?
We already sell it to lots of the major companies out there that are using it in the fabrication process as well as the bonding and joining process. So for fittings, no problem, same principle. You're just going to keep the heat moving. You're going to add the flux so that we can get the flux down into the fitting, and then you're going to lay the rod. And you'll just heat the rod right around the fitting. So it's perfect. Works exactly the same way and can fill in some beautiful gaps. I've seen some of our techs out there fill in a quarter size hole in aluminum just by breaking off the rod and minding their heat. So they're breaking off the rod, filling out the quarter, and then introducing the heat, and the flux just brings the metal, all the rod together. It's beautiful. Something else that goes along with that is you don't have any slag or BBs or teardrop into the line. So even in a microchannel, you're not closing off the line, which happens with almost all of the other product on the market today. This does not, and it's beautiful when it flows. So you don't have to worry about impeding the flow of that line with this product, with the alloy sol product.
So let's talk about what are the limits of what this can do. You talked about thermal cycling, which is increasing and decreasing temperature, that it holds up well to that. But is this going to work in a evaporator coil on a heat pump on an R410A system that could be potentially exposed to 400 PSI plus?
So that brings up a great point, as this is the strongest solder on the market. And I don't say that lightly. It is a 30,000 PSI bond. So you are well in your range with any kind of aluminum. You'll blow out another section of the line before you will even cause any stress or issue to the deposit that you just made. So that aluminum fix that you just made is now stronger, in fact, than the parent metal. So a 30,000 PSI bond. On top of that, Brian, this has been tested in all climates, in very, very cold climates, all the way up into Alaska, Canada. There's some very cold climates, and I'm sure we've got some Canadians listening in right now that are smiling, I'm sure. We enjoy our neighbors in the north, although it, in some points, gets pretty cold. And they love the aluminum. And then, of course, you have down in Arizona and Texas and Mexico and down into Brazil, the temperatures, whether we're on the coast and we're dealing with the salt environment, Hawaii, very salty environment. And we see a lot of corrosion, and we have to deal with that with the copper. But with the aluminum, we don't have to worry about it. And with this fix, you're not going to have to worry about it. The other side of that, too, that's backed up on that is something that is very important we understand is we should clean it after we're done with the repair. Not because we want it to look pretty, but just simply to take off any additional flux that's there.
Yeah, anytime you flux a joint that I'm aware of, you always want to wipe the flux off at the end. How do you feel about, because some techs like to apply wet rags and things right after they've made a repair. How do you feel about that with your product?
That's really interesting you said that. We just got done with an aluminum repair, or aluminum coil repair training at one of the larger HVAC companies here in Utah. They asked the same question. They said, we want to come at it with a wet rag. Because the temperatures are so high with brazing copper, we want to cool it off quickly and bring the temperature down. But with this aluminum, you remember you're at 600 degrees. It's really not as hot as we're dealing with in a brazing scenario, but immediately it will set within 10 to 15 seconds. And so you can take a wire brush and a little bit of water and you can go at it right away, 10 seconds, 15 seconds later, and you've got a bond that is beautiful.
Another thing that's an advantage of doing low temperature repairs is that you don't have to worry about the buildup of oxides inside the copper like you do while brazing. So when we're brazing, we have to be so concerned about flowing nitrogen while we braze so we don't contaminate. But when you're down at 600 degree range, you're not going to have any of those concerns as well.
Exactly.
Not that there might not be other reasons that you want to flow. You want to flow nitrogen to make sure that you displace any refrigerant or whatever, so you don't have phosgene. There's some other reasons that you might want to flow, but it's not necessary as far as the oxide buildup. From a temperature standpoint, though, we wouldn't want to ever put it in an application that's going to go over 600 degrees because then it would melt it. But in HVAC, I mean, really the hottest you could probably ever see in a system that had a problem even would probably be about 300 degrees on a discharge line. So you're still not even really close to that point.
True. However, just understand on this, the aluminum melts at 1190 degrees. This deposit, once it sets, won't remelt till the aluminum melts itself.
Oh, interesting.
So you're upwards of 1600 degrees that this deposit will remelt. Your aluminum line is already melted by that point. Okay, so the deposit stays. So no worries about remelt, just the initial melting and chemical combination to the parent metal and the rod is at 600 degrees. You mentioned AK HVAC, Andrew Greaves. He did, for his very first try at this, he did his very first brazing on aluminum, his very first soldering on aluminum. And he said, I only needed a couple of practice tries. And if you look at that YouTube video he put up, it's just fantastic, Brian.
Andrew's kind of a special guy. He's got a little bit of that like Thor God thing going on. So I'm not so sure. I wouldn't necessarily want to trust that too much. I think it might be the magic in the beard. I'm not sure.
It's probably that. You're right.
Could be. So some people have mentioned, and I don't know that I would necessarily try this, but I want your opinion on this. Some people have mentioned practicing on an aluminum can. What do you think about that?
The aluminum can is more of a swap meet trick than anything. Guys laugh about, well, I can braze two cans together. Sure you can, because it is low temperature. However, the problem is that aluminum can is so thin that you literally have to have a pinpoint flame so that you're not spreading out the flame and melting the other areas of the can. But yes, I've many times have put two cans together or filled a hole in the bottom of a can. I'm not sure why we would need to do this, but sometimes it's just for fun. I guess if you're out at the dunes and you're drinking beer and you get a hole in your can, I guess you could fix it. Sure.
There you go. Make sure to always keep your alloy sol with you just in case you ever get a hole in your beer can. Okay, maybe that's a bit of a stretch. All right, so let's talk a little bit. We didn't start off with talking about SolderWeld and a little bit about your company. Tell us about SolderWeld, how it got started, and maybe what the future looks like.
SolderWeld itself is actually got started years and years and years ago in the auto industry, and very big in the auto industry for fixing aluminum lines and radiators. And the off-road industry started to really take the excitement of it, because if you're out in the middle of the desert or in the dunes or on a trail and you're in a UTV or your motorcycle and you get a hole in your case or you get a pinhole in a radiator, in the past, you're done for. Or you're throwing some JB Weld on there and hoping you can limp back to the trailer. So SolderWeld started out with the idea that, listen, we can fix this, and we're one of the only companies out there that has this technology. The aluminum rod just keeps getting better and better and formulated to work with the different industries to be the most effective. So we began to then get into the auto body industry, and the auto body industry started looking at our aluminum alloy sol rods and flux and realized that with aluminum introducing itself in the auto body side of things with the new F-150s and body panels, that this low temperature rod was one of the only rods on the market that could actually fix a body panel or aluminum on a vehicle. And so it became very popular at the SEMA show. And of course, we do the SEMA show every year down in Las Vegas. It's a huge, huge car show. I highly recommend it. And a few years back, we started looking at the HVAC industry. We had already been getting calls from refrigeration techs wanting to know if our products would work with this application and that application. Of course, many of you are probably very familiar with the heat absorption putty that took off and is very popular in the market now. It's called Hot Block. And that really gave us, if you will, that footprint to show the HVAC market. We're the only company out there that is training on this. We're the only company that is trying to get out in front of as many HVAC companies and show them that there is a possible fix to aluminum. And it's not only about having the right product, but it's about having good technique. And if we can teach and educate on how to do this, then guys will have no problem taking the alloy sol and flux and putting it in their truck. And anytime they run into an issue or somebody backs their RV into their coil and you've got to fix it, it can be fixed right on the spot without much problem or issue, without having to worry about having to come back and repair it later. There's nothing worse than having to come back 6 months later and having to fix the same thing that we're supposed to have fixed before. So SolderWeld started taking off and getting bigger and bigger. We started getting interest from outside of the US, distributors that wanted to move the product throughout Australia, New Zealand, all throughout Europe, and into the Middle East, of course, and South America. And we continued to grow, but I will tell you, we have a very difficult time. We're a small company. We're a family-owned company. And as a small company, we have a very difficult time competing, Brian, as you know, with some of your major brands out there, such as your Harris and your Lucas and your Worthington. But all of our products are American made, and we do our best, our absolute best, to give you the same prices or better. And SolderWeld, we stand behind everything that we do, and we're just trying to make our mark. We're trying to give people a great American made product that will last and will be something that they can count on from here on out.
I really like your products. I really like what you're doing with the education side. I like the fact that you are American-made products. And there's a lot to like about SolderWeld. So we have a lot of listeners who are contractors, a lot of them are technicians, and then we also have a lot in the distribution world. So for anyone who may be interested in learning more about your products or maybe seeing if they can get a training or something like that, what would be the best way for them to get in touch with SolderWeld?
Easiest way is they can come right on to the website at solderweld.com and email us at info@solderweld.com, or as well, they can give us a call on our 800 number, which is 1-800-356-8449. Contact us. Let us know that you're interested in having us come out for an aluminum coil repair training at the company. We do it on location. All we ask is that you try and track down an old aluminum coil so that we don't have to try and ship something out or carry it on the plane, which doesn't happen. And we'll be there. We'll show up and we'll train and we'll educate and we'll make sure that every tech there is up to speed and trained up on fixing aluminum coils and fixing all types of aluminum. And then we'll also go into detail about low temp bonding, because something that Brian, you and I haven't talked about, and it's probably for another day, is copper to aluminum and dissimilar metals. And we have one of the best rods and flux on the market for dissimilar metals and low temp bonding. So we'll talk about that. And of course, we're happy to jump into one last thing. We'd love to provide Silphos, even though this isn't a premium product. This is something that everybody has out there and they buy it. We would love to be able to have you using American-made SolderWeld Silphos 15%. But we're happy to manufacture whatever your company needs. We're doing our best to stay ahead of the market. And as a small company, it proves to be a challenge, but we're doing what we can.
Contractors out there, when you're at your distributor next time, ask them about these SolderWeld products. Ask them about alloy saw and the other products that SolderWeld makes. And if they don't carry it, ask them to carry it. That's one of the big influences you can have in the marketplace. I'm a big believer that the best products in the marketplace should be the winners, and every manufacturer should be willing to compete in the arena of ideas, and I think SolderWeld's making all the right moves. And thank you, Lance, for doing what you do, and I'm excited to use more and more of your products going forward at Kalos. I'm also excited to see where things go with SolderWeld. Thank you for doing what you do.
Thank you, Brian, for having me out. I appreciate it, and thank you, everybody, for tuning in. Appreciate that. Have a great day.
Hey, thanks for listening to this podcast and for getting all the way here to the end. That means you're either a loyalist or you forgot to hit stop and your podcast is still playing. Maybe it's playing in your pocket, but either way, I appreciate you for even starting to listen to the podcast. And I thank Lance for coming on. I really do like SolderWeld. SolderWeld is not a sponsor. There's no money changing hands. Some of you may think, oh, he's just paying. No, absolutely not. Actually, I just happen to think SolderWeld's a good company. They're an up-and-coming company. They're a family-owned company. They're a U.S. company. And they're really focusing on the HVAC industry and focusing on training. And to me, that is what makes a great company that we should all get behind and support. So throw your support behind SolderWeld. Shoot an email to Lance. Let him know that you heard him on the podcast and that he did a great job. I'm sure he would appreciate that. So if you haven't listened to the other podcasts in the Blue Collar Roots family, I would suggest that you go to bluecollarroots.com and take a quick look. We have the new podcast, which is the Electrical Code and Tips podcast. If you are interested at all in knowing more about the National Electrical Code and some good electrical tips, I think that's a great one. Building HVAC Science is a really good podcast with Bill Spohn, been out for a while. The Tool Pros podcast with Brent Ridley and Billy Noth is a great show. that I think you'll enjoy. They just recently had an episode on hammers, actually, of all things, but it was actually a really good episode. I enjoyed it. And then Service Business Mastery. Been on a little hiatus recently while Tersh is getting everything rolling in his own business, which you will hear if you listen to Service Business Mastery. It's not only giving you great tips for business, but also taking you along the way in, shows you kind of Tersh's journey growing his business from its infancy up until what he wants to create in the future, which I think is a pretty interesting format. So you can listen to all those shows by going to bluecollarroots.com. Another thing you may not know, I don't know if you've ever read the Communist Manifesto. Most of us are red-blooded Americans. We're not into that sort of thing. But actually, the Communist Manifesto was written in all lowercase letters. And that's because Karl Marx didn't like capitalism. All right, thanks for listening. We will talk to you next time on the HVAC School Podcast.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.